What I want to highlight here is the difference between a operation that is an aggregation and one that is transformative. An aggregation will reduce our results from, say, n rows down to 1, for example, whereas a transformative operation will be n to n. And pandas lets us do this very seamlessly. So let's go ahead. We're going to create a new table here, and let's populate it with some values here. Again, we have dates, category, facet, and then 2 numeric columns. In our first pandas example, I simply want a cumulative sum of the column. So take our numeric value 1, cumulative sum, all the way to the bottom, and if you can nest that in a group by, then perform the cumulative sum. I would also be very interested to see that, because I think the cumulative sum, you can do it in SQL, but you just can't think of it how you would doing it in pandas. So James, can you perform a cumulative sum?
So, when you're dealing with SQL operations, you always have to think about how they transform the underlying table set, tuple space that you're working with. And so, for example, if we start with, as we always do, A, B, C, and D tuples, and we think about how these would be transformed, and we think about how this maps the different operations we have, well, what we can see is that, let's get this written up. There we go. And you could think each one of these is tuples. Well, a group by operation in SQL specifies what the output is going to look like. It specifies that after filtering via the where clause, you get non-overlapping partitions of the data set. For each partition, you get one result tuple. So you get one result tuple here. This result tuple must have each one of its result tuple values based off of some aggregation function of these initial values. And you can use that having clause to then further limit this down to which of the groups that you want. So if you had, X's and Y's come out of these, you can then limit it further with the having clause. But what that means is you cannot use the group by to do things like cumulative sums, at least not without some additional contortions. Because the cumulative sum says whatever the input shape looks like is going to look like the output shape. This is why when you look at SQL, you often see that there's a very different flow chart in play than when you look at pandas. In pandas, you say anything that's operating on a group goes through group by. In SQL, you say anything that's trying to produce an output based on a grouping goes through the group by. Anything that's trying to produce an output based on the original tables with some grouped operation goes through a window function. So with pandas, you think about it in terms of, well, what's the operation I want to perform? In SQL, you think about it in terms of what's the result set that I want to generate. And you could think pandas is much more mechanical and SQL is much more declarative, and that kind of fits to the feeling of it because you really never know how the SQL is executed. Whereas with pandas, you can often just guess what's actually happening behind the scenes mechanically. Now, with that said, I've just spent just enough time in the back of my brain to figure out how to do this. You're going to do a, let's do a select star from our data. And let's quickly redefine. We're going to do a cumulative sum grouped by categories, right? So let's get each original data point that we have. And let's just add in the cumulative sum. And here this would just be a sum of the value 1 over a partitioning by the category. And if we do this, we get the total sum. We get a transform sum like you'd have in pandas. But if we do an order by the category, this makes it an ordered window. And so let's call this as sum. And I guess this should be. So we partition by the category, order by the category. Oh, no, we want to order by the ID. Yeah, there we go. So you can see. And then let's do a filtering on this. Let's say where category equals cat 0. And let's limit this to 10, and let's just eyeball it and see if it gives us what we want. Oh, and we don't need the limit there. So does that look like a cumulative sum per the category? Yeah, it looks like a cumulative sum per category.
To me.
There you go.
Oh man, I have to admit, I was trying to hide the mechanics from you, but you nailed them right on the head. In pandas, you can actually perform an expanding window operation. And all this is doing is it looks at the first value, performs some computation. Then it looks at the first two value, performs computation. First three, and so on and so forth. And so another way to write this cumulative sum is to actually explicitly tell it, use an expanding window, sum everything in that expanding window and give it back to me. But I was trying my best to hide those mechanics from you, but you sniffed them out and translated them into SQL flawlessly. Okay, now for my next question here. How do you demean a data set? And by demeaning, I just want you to subtract the mean of a given column from all the values in that column. Shouldn't be too hard, but can you demean after a group by operation, such as this? In pandas, we would perform the group by, we would use .transform instead of aggregate. And what this does is it will calculate the mean for each group, and it will broadcast it back, that same group mean, back to every row that has that group, so that our data set has the same shape as it originally did. And so what you can see here is when I perform this, you see I have the same 400 rows that I started with in my mean, and they are all aligned by which facet they came from. And from there, it's just a simple subtraction. So James, can you demean a grouped data set in SQL?
I can tell it that it's worthless and it'll never amount to anything, and that's sufficiently demeaning. In this case, however, to reduce the values by the group mean, I think likely answers itself. We want to have one row per each individual starting row, so that necessitates the approach that we take. Once you really see the patterns behind how SQL works and the mental models, oftentimes instead of trying group by and then you bang your head against the wall and it doesn't work, you go straight to what you want. And again, this is going to be a window function. I don't think that I've ever done something like this in SQL. I've done it a lot of times in pandas, and I can't remember the last time I did something like this in SQL, but here's my guess for what this would look like. I would first start by looking at everything. Okay, that's my starting point. And by the way, your select star is one difference between SQL and pandas. I don't know what the pandas equivalent of. Select star, make sure you're still alive, make sure the data set still exists, make sure you're still connected to the database. I guess that would just be like print df. No, that would be like df at the end of your df.sample at the end of your at your cell. Okay, now what I'm going to do is I'm going to select the data, all of the data, from my data set, and I'll continue to limit it, just so that I don't spam my screen. I'll pull in the value 1 here explicitly, and I'll call it demeaned value 1. So that gives us that. And then what I'm going to subtract from this is my average of value 1 over a partition by the category ordered by the ID. No, I don't need to order it because I just want the whole group category. So I just do like that. And that should give me my demeaned values per category.
That looks right to me, right? Everything's hovering about 0. And I believe all the values from value 2 were from a uniform distribution, so we would expect a lot of values to be hovering around that. Yeah, it looks good to me. Wow, you crushed that one. But I think what we have next might be just a little bit more tricky, a little bit more SQL thinking. In pandas, we can actually grab the rows from some column that happens to have the largest value. What we can then do is nest that within a group by. If it wasn't, already tricky enough to select max rows where maximums occur, we can actually throw that in a group by, such that for every group of category that we have, we select the 3 largest values from value 2. And so you can see here in our output, we have indeed grabbed the 3 largest values. They're all close to that upper bound of what we did grab them from. And if that might seem a little on the easy side to just add a little bit more heat, I'm actually not sure if this is doable in SQL, but we have the group by apply here. I want the entire row where those maximums occurred. So the 3 largest values from each group and the entire row where those values occurred. Is that easily doable in SQL?
So one of the things that we can see is with especially the group by apply, you can define how large the result is as part of the apply.
Yeah.
Whereas with the with the SQL group by and window function, it's usually the syntax that is very strictly defining what the output looks like. I have to go back to my core SQL, how does this actually work thinking to think about this. We have A, B, C, and we're looking for some grouping. So we want to group these in some fashion. And then based on that grouping, we want to figure out what the top 3 values are. And we cannot do that with the group by because fundamentally the group by itself will only give us one value. And it'll only be able to give us what the aggregate function is. It can't give us what the row is. Because when you do the group by, you can only compute either the grouped value, the unique grouped value, or you can compute computation on the individual tuple entries, on the entries that you have, but you can't say, oh, just give me this thing over here that happened to laterally have this. That requires some sort of join mechanic. And so I suspect I can break this down. And the way I would break this down is to first, no, I can do it. And I can do it with the window function. I can do it by ranking the data first and then filtering. So what I'm going to do is I'm going to preserve the entire data set, and I'm going to use a partitioning via the window function to rank them within their groups. And then, based on the ranking, I'll filter to eliminate myself down to this. So you can see, because I can't control what the output size is via the direct syntax, I always control that output size via either some group by, which is collapsing to a group, or via some filtering, a where or a having clause. And so that tends to be, and this is a great, great question, because you can see in the absence of being able to control the size in the same mechanisms that you have in pandas, you control it via first constructing everything, then pulling the size down. And you can think why this might make sense. In pandas, you might need to have fine-grained control over the size because it's in memory. And you want to control how much memory you allocate. You don't want to over-allocate memory and then throw it away. Whereas in SQL, because it's more declarative, it figures out how much memory you want, and it might do some sort of heuristics to try and guess that, but it's not really as limited in terms of store everything in memory. It's trying to minimize not the memory that you are allocating, but the number of disk reads that you're performing. And so it doesn't give you that fine-grained control in that fashion. So let's do this. Let's select star from data. Let's make sure we're still alive. Okay. Then what we want to do is we want to rank within the category, right? So we want to do rank of the value 1, is it? Yep. Over a partition by the category. And let's see here, and let's order this by, let's see if this works. No, we want the rank. This is, let me think. And here I have to remember the difference between Postgres and MySQL for how it does the ranking. In MySQL, you can do the rank as a function. In Postgres, I have to remember, is it rank or dense rank? Oh, you know what? I'm going to rank order by. That's what I do. I don't tell it what to rank by, I order by. So I do rank like this. And so that gives me these. And if we eyeball this, we can see, there we go. And
large values have high rank.
Yep. And then what I'll do is I'll call this as rank. And then I should be able to do a having clause. Rank is less than or equal to 3. And here, because I can't access this column in the having clause, what I do this is a subquery. So I do, select star. I first construct this, and then I do a where clause. Different database languages kind of let you do a little bit more in the having clause. That is to say, MariaDB's database engine does allow you to do some things in the having clause that Postgres doesn't allow you to do. And here we go. And that should give me the top 3 values. And what I want is I want a dense rank, so there's no ties. So that should give me, I don't know, I want a, that's interesting. Here, it looks like there's a bunch of ties in there, so I can do the, how do I want to do this? I just have to go into the window function and see how to get the right kind of a window function for the rank.
Yeah.
But I think you get the general idea.
Yeah, exactly. And I'm glad you brought up one very good point about this group by apply being so flexible, right? You can pretty much return anything you want from it, and pandas will do its best. One thing that I want to note about group by apply is that it does what we call a sniff test. It will actually run your operation on the very first grouping, and it will check the output. It will try and make some assumptions about that output as compared to the rest of the output in order to pre-allocate some memory or speed up the computation. So pandas does do a little bit of its own optimization. Obviously, it's not as heavily optimized as SQL.